Hello children, in this video I'll be discussing about refraction of light. There's a new phenomenon introduced to you. You haven't got it in lower classes, so in class 10 you are getting refraction of light. Now what is refraction of light? Suppose if you enter into a swimming pool, your leg or your body seems to be smaller, or you move a pencil behind a bottle which is filled with water, you'll find that the pencil looks thicker. So all these occurs because of the process called refraction of light. So what is refraction of light? The definition is that it is the phenomenon of bending of light rays either towards or away from the normal. So you know always there is a normal. So the light ray, it will bend either towards the normal or away from the normal. When light passes obliquely, it will not be perpendicular, it has to enter obliquely from one medium to another. So basically refraction of light is nothing but bending of light rays. Bending of light rays when light travels from one medium to another. Okay. And both the medium, they should have different optical density. Optical density is slightly different from the normal material density. Optical density gives us an idea about the bending capacity of a medium, how much they can bend the light. So with the help of this diagram, we can try to understand. There's an incoming ray, incident ray. There's a rarer medium, there's a denser medium. There's the separating boundary of the two medium. So when light travels from a rarer to a denser medium, under normal condition it should have gone straight, but since it is traveling from rarer to denser, it will bend towards the normal. That we'll discuss in the end of this video, that why towards and why away from the normal. And if light, now this is called the refracted ray and this is the normal. This angle between the incident ray and the normal, it is the angle of incidence, and this angle between the refracted ray and the normal, this is the angle of refraction. So make it, pronunciation should be very clear, otherwise you will get confused between refraction and reflection. When light travels from denser to rarer medium, then what happens? The light is coming, it should have continued like this if both the medium would have been same, but this is rarer, so this light is bending away from the normal. So this is what happens in case of your refraction. So there are two laws of refraction here. First law is that the incident ray, refracted ray and normal all will lie on the same plane. Here the plane is the plane of this copy. And second is ratio of sine value of angle I. In class 10 you will get trigonometry, so you will have sine, cos, tan, all these trigonometric function. So the sine value of angle I to the sine value of angle R is always constant. So if you take the ratio of sine of angle I by sine of angle R, it is always constant for a pair of given media. So suppose you take a pair of given media, your pair is, suppose light is entering from air to water. For that particular pair, the ratio of sine value of angle I by sine value of angle R, whatever will be the angle I, angle of refraction will change, and ultimately the ratio will give you a constant number. So it can be written like this: sine of angle I by sine of angle R is a constant, and this constant is called refractive index, which we write using letter mu or n. Normally we prefer the letter n. This law, this second law, it is also known as the Snell's law. Now we'll discuss different other phenomenon related with refractive index. So refractive index can be expressed as the ratio of speed of light in two medium. So in earlier part we have seen that refractive index was described as the ratio of sine value of angle I by sine value of angle R. But refractive index can also be expressed as the ratio of speed of light in two medium, because when light travels from one medium to another, its speed changes. So suppose this is the incoming ray, this is the incident ray, this is the refracted ray. This medium 1, let us take it to be rarer, this medium 2 denser, so it is bending towards the normal. V1, let us take it to be speed of light in medium 1, and V2, speed of light in medium 2. So how we write refractive index? It is written as n/1. Now what is n/1? I will be telling you. So how it is written? Speed of light in medium 1 divided by speed of light in medium 2. That means the medium through which light is coming, that medium speed you have to write on top, and the medium into which the light is entering, that speed you have to write below. So it is written as n/1 V1 by V2. V1 is the speed of light of the medium through which light is coming, and V2 is the speed of light of the medium into which light has entered. Now it will give you refractive index of which medium. We have written it as N21. It means refractive index of medium 2 with respect to medium 1. So when we are writing like this, it is describing the refractive index of the medium into which the light is entering, not the medium from where light is coming. So it is the refractive index of medium 2 with respect to medium 1. So you should remember one point, that greater the refractive index value, more is the bending of light towards the normal. Okay. So now when we talk about refractive index is of two types: relative refractive index and absolute refractive index. If someone asks you what is refractive index, you can simply say it gives us the idea of the bending capacity of a medium. More the refractive index, more is the bending capacity. So what is relative refractive index? This is relative refractive index. That means refractive index of one medium in relation to another medium. That is called relative refractive index. Now, what is absolute refractive index? Absolute refractive index is a special type of relative refractive index where the medium through which the light is coming, the first medium through which the light is coming, that is always air or vacuum. And in relation to air or vacuum, when you describe the refractive index of any medium, that is called the absolute refractive index of that medium. For example, in your textbook also, you will get a list of different refractive index. So suppose I'll show you a list here. So if you can see, so this entire list that is shown here, there's the list of the absolute refractive index. Suppose water, it is given as 1.33. So it means it is the refractive index of water with respect to air or vacuum. Suppose glass is given as 1.5. So it is the absolute refractive index or refractive index of glass with respect to air or vacuum. So whenever we talk about absolute refractive index, it is with respect to air or vacuum. So refractive index of medium expressed in relation to speed of light in air or vacuum is called absolute refractive index.